Hello guys, and welcome to the last part of atomic structure and nomenclature. In today's part, we're going to be going over acid and bases. So, to begin with, what are acids? Acids are made of monatomic anions, and their names are based on the monatomic meaning one, so the monatomic anion, right? Anion. So the monatomic meaning one atom, and it can also be made by polyatomic ions. Polyatomic anions, right? Or oxide anions. So, polyatomic anions. So, quick thing is that acids, their chemical formula for acids always has a hydrogen in the beginning, right? So, for example, with a monatomic anion or one atom, it could be chlorine, right? So it would be the hydrogen and the chlorine, and this would be a form of an acid. And so how do we say these acids? So since it has the hydrogen in the beginning, for monatomic anions, we include the prefix, let me write this with a different color. We write the prefix hydro, right? Hydro. Then we state the base name of the monatomic anion, so hydrochlor, right? Chlor. And then we add ic to the suffix ic, and we simply finish it off by saying that it's an acid. So the form of saying this HCl would be hydrochloric acid. Now we see that a monatomic ion just means that it's one atom, so we can also do, for example, this hydrogen with bromine, right? For example, so we still have the same prefix hydro. We name this as hydro with a hydrogen in the beginning. We would write the base name for bromine, so hydrobrom or brom, right? Brom. Let me brom. Ic, hydrobromic acid, right? Hydrobromic acid. And so this is the way you would typically name monatomic anions, right? Or these single atom anions. Now, how do we name polyatomic anions? So, in order to name polyatomic anions, we know that the base form of a polyatomic anion has 8, right? But when we have less, it has 8, right? Less oxygens within the polyatomic anion. Now, how do we say a polyatomic anion acid with an acid, right? So we would still write the hydrogen in the beginning, for example, this H, but now let's use chlorate, for example, HClO3, right? Now know that it's a balanced, right? The hydrogen has one proton, meaning that it has a positive 1 charge. Now the chlorate, on the other hand, has a negative 1 charge, but this negative 1 and this plus 1 cancel out to be 0. So they have a positive charge, and therefore there's no more subscripts of hydrogen or chlorate in this example. You can think about this formula as having parentheses here, right? And so this is one whole molecule, this is another molecule. So we have this chlorate polyatomic anion. And so how would we name this? Now you would think that because it has a hydrogen in front, it would be named similarly to the monatomic anion, but it actually does not have this hydro prefix. So the hydro prefix is not there anymore, and so we just continue with the polyatomic anion name. So it is chlorate. However, it is not said as chlorate acid. instead, this 8 changes to ic, and this ite changes to us, right? Or OUS. Now, in this case, it has the reference number of 3, so it has its base form of chlorate. So then we would change this to chloric acid, right? It would just be known as chloric acid. Chloric acid, right? Now, what happens if it loses its oxygen, right? For example, we have HClO2. Right? Now, they still have the -1 charge and the +1 charge, so this is balanced. And so now we still have the base form. Remember, we don't use hydro when talking about polyatomic anions in conjunction with acids. So we use the chlor, the base form, and instead of ite, which is this would be chlorite, we would use chloris. Alright. So in this case, this would be known as chlorous acid. Right? Now, let's say we have the same thing with even less oxygen. Right? So in this case, hypochlorite used in an acid. Right? So we still have the hydrogen, and think about it like this, and we have the ClO, right? Hypochlorite, and in this case, you would actually use the prefix of this hypochlorite. So it would be known as hypo, chlor for the base name, and since it's still an ite, you would use the us suffix, so it's hypochlorous acid. Same thing can be told from the perchlorate, polyatomic ion, right? For example, we have the hydrogen, and then we have the ClO4, meaning that it has one more oxygen, so it becomes perchlorate, right? But since it's an 8 and it's an acid, it becomes ic, so it's a perchloric acid. Right. Now, a good way to remember how to change 8 and ic, 8 to ic and ite to us, is by using this mnemonic right here. I ate that horrendous bite. Ick. I ate that horrendous bite. Right? So here we have the ick and the ate together, and then we have the us and the bite together. Right? This is a good mnemonic to remember the change from chlorate to chloric, or the ate to ick, and the ite to us, such as chlorite to chlorous acid. Right? Now that's as much as it goes to acids. Another thing to know is that, as I mentioned before, they do have to be balanced. For example, let's take another polyatomic ion that does not have a -1 charge. For example, sulfate, right? So sulfate has a, let me use a different color for that. Right. So sulfate has SO4, but it has a -2 charge, right? And hydrogen comes in with a positive 1 charge, or 1 plus, right? So in this case, 2 minus 1 is still 1. So we don't have a balance or a 0 net charge for the total charge of this acid. And a way to fix this is simply by adding another hydrogen, right? So if we add another hydrogen, we would have 2. So this is a 2 minus 1, and this equals 1, right? So it's a negative 1, since it's a negative 2. So it's a negative 2 plus 1. It would be a negative 1 charge. And so we want this to have a net charge of 0. So in order to change this, we would need 2 more hydrogens, right? Because in that case, it would be negative 2 plus 2, and that would equal 0. Or simply, as stated in previous videos of the same lecture, you simply put the 2 as a subscript for hydrogen, and that 1 for the subscript of the entire sulfate, not for just that single sulfur or that oxygen atom, but for the entirety of that sulfate. So instead, now, for it to be balanced, we would have H2SO4, right? H2SO4. And in this case, then it would be balanced. And then to name this, since it is sulfate, and it's the base form of sulfate, we would simply name this sulfuric acid. Right? Sulfuric acid. And I hope this helps as to naming acids in this particular video. Hopefully you learned how to name acids through this way, and remembering this mnemonic really helps out a lot. Now, let's go on to bases. Now, when it comes to naming bases, you might find it a lot easier in comparison to naming acids, right? So, a common identifier of bases is the hydroxide, right? A common identifier to knowing what a base is the hydroxide molecule. Hydroxide molecule, which is OH, right? And this should be known that it has a negative 1 charge. A negative 1 charge. Now how bases are typically bonded with metals, right? Typically bonded with metals. So you typically have a metal and then a hydroxide bond. So for example, let's take sodium, right? The elemental symbol for sodium is Na, and Na, sodium would have a positive 1 charge, right? Sodium would have a positive 1 charge, and so you would add it to this hydroxide, which has a negative 1 charge. And so we see that that negative 1, or that positive 1, minus that 1 would equal that net charge of 0 that we were talking about. And so in this case, they would simply be named as sodium hydroxide. Right? Hydroxide. Right. And these are your typical common bases. When they have hydroxide, it's a easier way to know that it's a base. And so acids, they should have the name of acid within it, but you would typically know by the ic or the us, and knowing if it's attached to the hydrogen or if it's attached to a monatomic or a polyatomic anion. Right? Now you should know that not all bases follow the same naming system. There's a lot of bases out there that will trick you into thinking that they are either just an element by itself or a different form of an element, but we won't be covering those in this video, but we'll be covering later on throughout the sections. Now, I hope you guys were able to learn something today. I wish you all well, and if you guys have any questions, please feel free to comment down below. Like and share the video to as you seem fit, as however you guys would like. I'd really appreciate it, and I'll see you guys next time.